Why is the sky blue, but space is black? This audiobook answers a question we've all asked ourselves, but few truly understand. From how sunlight scatters in our atmosphere, to why there's nothing in the vacuum of space to make it shine, we'll explore the optical and cosmic keys to this contrast as everyday as it is profound. To begin, it's fundamental to recognize that light is a form of energy. But how can something so ethereal transform our visual experience of the world? The light around us, whether from the sun or a bulb, travels in waves, and each of these waves has unique characteristics that determine the color we perceive. Just as sound can vary in frequency and create different tones, so does light. Can you imagine a rainbow? That mix of colors is the result of light breaking down into its different wavelengths. The Earth's atmosphere plays a crucial role in this phenomenon. This layer of gases that envelops us is not only vital for life, but also acts as a filter that affects the sunlight that reaches us. Have you ever noticed how the sky can vary from bright blue to cloudy grey? This is due to the way the atmosphere interacts with light. The composition of the atmosphere, including oxygen and nitrogen, influences how light is scattered. Without this protective shield, our perceptions of the sky and space would be radically different. When we look at the sky, it's easy to wonder, why is it blue during the day and black at night? This phenomenon can be understood through a concept called Rayleigh scattering. But what does that really mean? Imagine that sunlight is like a group of friends arriving at a party. Some are tall and others are short. The taller friends are like the longer wavelengths, while the shorter ones are like the shorter wavelengths. When these friends enter the room, in this case our atmosphere, the shorter ones scatter more and therefore are the ones we see the most. This is the secret behind the blue sky. The wavelength of light also plays a fundamental role in the way we perceive colours. Shorter wavelengths, like blue and violet, scatter more than longer wavelengths, like red and yellow. So why don't we see a purple sky? The answer lies in the way our eyes are designed. Our eyes are more sensitive to blue tones, which makes the sky appear primarily that colour. But the show doesn't end with a simple blue sky. During sunrise and sunset, the sky is tinged with warm colours like red and orange. Have you ever wondered what causes this dazzling spectacle? At dawn and dusk, sunlight has to pass through a greater amount of atmosphere. This means that shorter wavelengths scatter even more, allowing longer wavelengths like red and orange to shine in all their splendour. It's a reminder that nature always has surprises up its sleeve. When we look out into the vast space, it's easy to feel like we're in an ocean of darkness. But why is it so black? In space, there's no atmosphere to scatter light, which means that starlight travels uninterrupted. This raises another intriguing question. If the universe is full of stars, why don't we see a bright sky at night? The answer lies in the fact that the vastness of space is so great that the stars are so far apart from each other that the light they emit is often not enough to illuminate the void around us. The expansion of the universe also plays a role in this perception. Just like the sound of a train moving away becomes sharper, the light from stars moving away from us shifts to longer wavelengths, a phenomenon known as the Doppler effect. This can make some stars appear dimmer or even invisible. The starlight we see at night is the result of journeys that have taken millions of years. Some of those stars we see may have ceased to exist, but their light continues to travel through space, like an echo of their existence. Isn't it amazing to think about the time and distance that separates us from each twinkle in the night sky? However, not everything is so clear. Light pollution in our cities can hide the beauty of a starry sky. Street and building lights interfere with our view of the stars, creating a veil that prevents us from appreciating the grandeur of the cosmos. The night that could be full of wonders becomes simple darkness. In addition, there are optical phenomena in the atmosphere that add another layer of complexity to the sky. Rainbows, halos, and reflections are just some of the wonders we can observe thanks to light and its interaction with the atmosphere. These phenomena remind us that light is not only a source of visibility, but also an artist that paints the sky with an infinite palette of colours. As we ascend in altitude, our perception of the sky also changes. In the mountains, the atmosphere is thinner, which can make the colours of the sky appear more intense and vibrant. The clarity of the air can reveal a visual spectacle that is hard to find in lower and more polluted areas. Planets and the moon also play a role in how we perceive the night sky. These celestial bodies not only reflect sunlight, but also remind us that we are not alone in this vast universe. The full moon can illuminate the night in such a way that it transforms the landscape, giving it a magical quality that invites us to contemplate the cosmos. Finally, when reflecting on the Big Bang theory, it's intriguing to think about how that primordial event affected not only matter, but also light and colour in the universe. The light that was generated at that instant has been travelling ever since, giving us a window into the past and a glimpse into the secrets of the cosmos. All this knowledge about the sky and space is not only fascinating from a scientific point of view, but also invites us to question our existence and our place in the universe. The way we perceive the sky and light connects us with a cultural and philosophical heritage that has accompanied humanity throughout history. As we explore these questions, we realize that the sky is not just a backdrop, but a vast ocean of mysteries waiting to be discovered. Light, the phenomenon that allows us to see the world around us, is much more complex than it seems at first glance. But what is light really? In simple terms, light is a form of energy that travels in waves. Imagine throwing a stone into water. The waves that form on the surface are similar to how light behaves. It travels in wave-like patterns, and these waves are what allow us to perceive the colour, intensity and direction of light. Each colour we see is the result of a specific wavelength. The colours that make up the rainbow, for example, are variations of light that move at different wavelengths. Did you know that white light, like that emitted by the sun, is composed of all these colours mixed together? When white light passes through a prism, it breaks down into the colours of the rainbow. This happens because each colour travels at a different speed and deviates to different extents as it passes through the prism. Thus, the spectacle of colours we see is nothing more than light in its purest form. Now let's talk about how light behaves when it passes through different media. When light enters water, for example, it slows down and changes direction. This phenomenon is called refraction. Imagine you're at the beach and you see a fishing rod submerged in the water. It seems like the rod is bent, but it's actually the effect of the light-changing mediums. The same thing happens when light passes through the air and enters our eyes. It adapts and adjusts to each new environment. Light is not just a physical phenomenon, it also has a significant impact on our emotions and how we perceive our surroundings. For example, warm light, like that of a sunset, can make us feel calm and relaxed, while cold light, like that of a cloudy day, can provoke feelings of melancholy. Have you noticed how a simple change in light can completely alter your mood? The interaction of light with different materials is also fascinating. Some objects reflect light brilliantly, like a mirror, while others absorb it, like a black shirt on a sunny day. The light that is reflected and the light that is absorbed determine how we perceive the colors of the objects around us. Isn't it incredible to think that the reason you see a banana as yellow is because it's reflecting that specific wavelength of light while absorbing all the others? As we explore more about light, we find that its behavior changes depending on the intensity and the source. Sunlight, for example, is much more intense than the light from a bulb. This not only affects how we see things, but also how objects behave under different light conditions. Have you ever noticed how colours seem more vibrant and alive under sunlight? This is because sunlight is richer in wavelengths that illuminate our eyes more effectively. Moving on to another aspect, it's essential to mention that light also has properties of both a wave and a particle. This may sound complicated, but think about the waves in the ocean. When we observe waves breaking on the shore, we see the movement of the water, but we can also think of each water droplet as a particle. Light behaves similarly. Sometimes it behaves like a wave, and other times like particles called photons. This duality is one of the most intriguing characteristics of light. Moreover, light can interact with matter in surprising ways. When passing through a colored gel, for example, only certain wavelengths are allowed to pass, while others are absorbed. Can you imagine what the world would look like if light didn't behave this way? The colours of flowers, birds, and even our own skin would be completely different. The speed of light is also fascinating. It travels at an impressive speed of about 300,000 kilometers per second in a vacuum. This means that sunlight takes only about 8 minutes to reach Earth. When we look at the sun, we're actually seeing what it looked like 8 minutes ago. It's like a time travel in every ray of light we see. Light also plays a crucial role in the life cycle of plants. Through photosynthesis, plants convert sunlight into energy, which allows them to grow and thrive. Without light, there would be no life on our planet as we know it. So the next time you see a plant, remember that it's using light to live. Finally, when talking about light, it's impossible not to mention its importance in modern technology. From fiber optics that transmit information at incredible speeds, to the way smartphones use light to capture images, light is fundamental to the advancement of science and technology. It's a resource that, although we often take for granted, is at the heart of many of our innovations. Light is a multifaceted phenomenon that impacts all aspects of our daily life. From what we see to how we feel, its influence is undeniable. understanding how light works not only helps us appreciate the world around us more, but also opens the door to new explorations and discoveries in the vast universe we inhabit. So, the next time you look up at the sky, remember that there's much more behind that light that simply illuminates your path. The Earth's atmosphere is like a large protective mantle that surrounds our planet. Its composition and structure are essential for us to live. But what exactly is the atmosphere, and how does it influence what we see when we look up at the sky? To understand this, we first need to delve into its components. Imagine the atmosphere as a soup. It is made up of different ingredients, each with its own flavour and function. Mainly, it is composed of nitrogen, which represents about 78%, and oxygen, which makes up about 21%. But that's not all. There are also small amounts of other gases, such as carbon dioxide and argon, as well as water vapour and suspended particles. These ingredients are fundamental to the balance of our environment. The atmosphere is not just a layer of air. In fact, it is made up of several layers, each with unique characteristics. The troposphere, which is the closest to the Earth's surface, is where all weather phenomena occur. Here is where we can find clouds, rain, and wind. If you look up at the sky and see clouds moving or hear thunder, it is in this layer where the action is happening. Did you know that the atmosphere also acts as a filter? When sunlight enters our atmosphere, it passes through all these layers and encounters different gases and particles. Some of these particles are small enough to scatter light, which affects the colours we see. For example, blue light is scattered more than red light. This is part of the reason why the sky is blue during the day. Air pressure also plays a significant role in how we perceive light. As we ascend in altitude, the pressure decreases, meaning there is less air and fewer particles to scatter light. In fact, if you've ever flown in an airplane and looked down, you would have noticed that the sky looks darker and deeper. This is because there is less atmosphere between you and space. Now, let's think about temperature. The atmosphere is not uniform. The temperature varies at different altitudes. In the troposphere, as we go up, the temperature tends to decrease. But in the stratosphere, for example, the temperature can increase due to the presence of ozone. This variation in temperature also affects how light behaves, creating different visual effects in the sky. Humidity is another factor we cannot ignore. When there is more water vapour in the air, the atmosphere can become denser. This can make the sky look greyer and less bright. When it rains, the water in the air acts like a mirror, reflecting and refracting light in fascinating ways that can change our perception of the sky's colour. Speaking of colours, have you noticed how the sky can look different in different parts of the world? In cities, where there is more pollution, light is scattered differently than in rural areas. This means that the sky can appear paler or even yellowish due to particles in the air. Thus, the atmosphere not only affects the colour of the sky, but also reflects the health of our environment. But what about starry nights? The atmosphere also plays a crucial role. During the night, when we look up, we are seeing not only stars but also light that has travelled thousands of years to reach us. Without the atmosphere, the sky would look completely different. We wouldn't have the soft shades of blue and violet that we see at dawn and dusk. As we delve deeper into the atmosphere, we can find interesting phenomena like auroras, which are caused by interactions between solar wind and particles in the atmosphere. These light shows are a reminder of how dynamic and vibrant our planet is. The atmosphere is a place of constant change and activity. In summary, the atmosphere is an essential component that not only enables life on Earth, but also shapes our visual experience. From the way we perceive light and colour to how we interact with our environment, the atmosphere is a constant reminder of the beauty and complexity of the world around us. Every time you look up at the sky, remember that you are observing a delicate balance of gases and particles that make our existence possible and add colour to our lives. Have you ever wondered why the sky is blue and not, say, green or red? This fascinating phenomenon is due to a process called Rayleigh scattering, which plays a crucial role in how we perceive light in our atmosphere. Imagine that sunlight is like a rainbow, a set of colours travelling together. When this light enters the Earth's atmosphere, it encounters air particles and other elements that affect it in surprising ways. Rayleigh scattering occurs when light collides with these tiny particles. But what does this have to do with the colour blue? The answer lies in the wavelength of light. Blue light has a shorter wavelength than other colours, such as red or yellow. Being shorter, it is more susceptible to scattering. So when sunlight passes through our atmosphere, the shorter wavelengths, like blue, scatter in all directions, filling our sky with that beautiful colour. Now think of it this way. Imagine a room full of balls of different sizes. If you throw a large ball, most of the small ones will move around it, but if you throw a small ball, they can move more easily and scatter in different directions. In this case, blue light is the small ball that scatters more easily. This leads us to ask, why don't we see the colour blue all the time? During sunrise and sunset, the sun is lower on the horizon, and its light has to pass through a larger amount of atmosphere. This means that shorter wavelengths like blue scatter so much that they no longer reach our eyes with the same intensity. Instead, we see warmer colours like orange and red, which have longer wavelengths. It's as if at those times the sky decides to change its wardrobe to display a different palette of colours. An interesting phenomenon related to Rayleigh scattering is how it affects the perception of the sky from different places. If you're on a high mountain, for example, you might notice that the sky looks bluer. This is because there is less atmosphere between you and the sunlight. However, if you're in a city with a lot of pollution, the sky might appear more grey. Pollution can interfere with light and alter how we perceive colours. Sometimes Rayleigh scattering can be so intense that it seems like the sky has different shades of blue throughout the day. On a clear day, you can observe a deep blue at the top, while on the horizon it may appear paler. This is part of the magic of how light interacts with our atmosphere. But what happens when we look into space? Space is an empty place without an atmosphere to scatter light. That's why, when we look at the night sky, we see a deep black dotted with stars. This darkness is a powerful contrast to the blue of the daytime sky. The absence of atmosphere allows the light from the stars to reach our eyes without interference. But here arises another intriguing question. Why do some stars shine brighter than others? The answer is related not only to the distance of the stars, but also to their size and temperature. Larger and hotter stars emit more light, which means they are more visible from Earth. So when we look at the night sky, we are seeing a mix of light that has travelled through vast space, and the Rayleigh scattering we experience during the day no longer has an effect. Returning to our daytime sky, it's fascinating to think about how the science behind Rayleigh scattering not only explains why the sky is blue, but also leads us to reflect on how we perceive the world around us. Light, in its essence, is not just a part of our daily lives, but also a window into the workings of the universe. This phenomenon is a reminder that science is present in the simplest details of our life, from the colour of the sky to the light we see. At the end of the day, Rayleigh scattering not only offers us a beautiful visual spectacle, but also invites us to admire the intricate design of our world. Every time you look at the sky and see that vibrant blue, remember that behind that colour is a story of light and particles that has been happening for billions of years. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this star odyssey. What exactly determines the colour we see in the sky? To understand this, we must delve into the fascinating world of light and its wavelengths. Light, that invisible phenomenon that allows us to see, is composed of different colours, each with its own wavelength. But what exactly does this mean? When we talk about wavelength, we are referring to the distance between two crests of a light wave. Imagine a wave in the ocean. If the waves are very close together, that means they have a short wavelength. On the other hand, if the waves are more separated, they have a longer wavelength. In the case of light, the colours we perceive range from violet, which has a short wavelength, to red, which has a long wavelength. Now, why is this so important for the colour of the sky? The answer lies in how light interacts with our atmosphere. Upon entering the Earth's atmosphere, sunlight collides with air molecules and other small particles. This collision causes the light to scatter, and this is where wavelengths play a crucial role. Short waves, like those of the colour blue, scatter much more than long waves, like those of the colour red. So, when we look at the sky, what we are really seeing is that blue light scattered in all directions. But what about other colours? It is interesting to note that although the white light from the sun contains all the colours of the spectrum, not all are scattered in the same way. Can you imagine what the sky would look like if red scattered as much as blue? It would probably be a quite different spectacle. Thinking about this, it's easy to wonder, why isn't the sky other colours during the day? Throughout history, many cultures have observed the sky and tried to explain it. However, modern science offers us precise answers. Rayleigh scattering, a phenomenon that occurred in the time of the scientific revolution, was fundamental to understanding why blue predominates in our daily views. Still, there's more at play. Light also interacts with larger particles in the atmosphere, like water droplets and clouds. When this happens, different effects occur, like the appearance of white or grey clouds. This leads us to wonder, how does the amount of water in the air affect the colour we perceive? And speaking of perceptions, we cannot forget how the quality of light changes as we move throughout the day. During sunrise and sunset, when the sun is closer to the horizon, the light has to pass through more atmosphere, which causes shorter wavelengths to scatter and the longer ones like red and orange to finally reach our eyes. Who hasn't enjoyed a beautiful sunset with its warm and vibrant tones? But what happens in outer space? Upon leaving our atmosphere, light no longer scatters in the same way. In the vacuum of space, where there is no air or particles to interfere, black predominates. This leads us to a fascinating reflection on the perception of colour in different environments. Why is space dark if the stars shine brightly? When we look at the night sky, we are actually seeing the light from stars that have travelled through space for years, even centuries. But the distance and expansion of the universe make that light perceived differently. Some stars are brighter than others, not only because of their size and temperature, but also because of the distance that separates us from them. Have you ever wondered how many stars there are in the universe, and how much light actually reaches us? As we explore these concepts, we can marvel at the complexity and beauty of the universe. Light, its behaviour, and its interaction with our atmosphere not only help us understand why the sky is blue, but also connect us with the cosmos in a profound way. Every time you look at the sky, you're observing a phenomenon that has been studied and admired throughout history. So the next time you observe the sky, remember that each colour, each shade, has a story to tell. Light, in its journey through the atmosphere and space, reveals not only the beauty of our world, but also the secrets of the universe. How can one not marvel at such a spectacle? The science behind the colours of the sky is a reminder that even in the everyday, there is awe and mystery waiting to be discovered. When the sun begins to descend on the horizon, the sky transforms into a vibrant spectacle of warm colours. Reds, oranges and yellows intertwine in a celestial dance. But why does this happen? What causes the sky to be dyed with these captivating tones during sunrise and sunset? To understand this, it is essential to delve into the nature of light and how it interacts with our atmosphere. Sunlight, although it appears white to the eye, is actually composed of a spectrum of colours. Each of these colours has a different wavelength, which means they travel at different speeds and behave uniquely when passing through the atmosphere. When the sun is high in the sky, its light passes through a lesser amount of atmosphere, and the colours disperse evenly, giving us a bright blue sky. However, as sunset approaches, sunlight has to traverse a larger portion of the atmosphere. Imagine the atmosphere as a giant filter. As sunlight penetrates this filter at sunset, shorter wavelengths like blue and violet scatter more, while longer wavelengths like red and orange manage to pass through the filter more easily. This interaction causes the skies to light up with those warm spectrums that are so characteristic of these moments. But why are red and orange so predominant? The answer lies in the way our eyes perceive light. Our eyes are more sensitive to longer wavelengths, which means that as sunlight scatters and filters, warm colours become more prominent. It's as if you were looking at a painting, where warmer tones stand out over the cold ones, creating a natural masterpiece. During sunrise, the process is similar, although there is a different nuance. the atmosphere is still fresh and clean after the night, allowing the colours to display with striking clarity. With fewer particles in the air, the colour spectacle that unfolds can be even more vibrant. This phenomenon reminds us that the sky is a constantly changing canvas. However, not all sunsets are the same. Factors such as humidity, pollution, and particles in the air can influence the intensity of the colours we see. On a cloudy day, for example, the sky may appear grey and monotonous, while on a clear day, the colours can be so intense that they seem dreamlike. So, the next time you see a spectacular sunset, think about the dance of light and atmosphere that makes it possible. Often, the beauty of the sky at sunset invites us to reflect on our place in the universe. The light we see is actually a journey of millions of kilometers that has taken time to reach us. Each sunset is a reminder that light and color are intrinsically connected to the elements of our planet and the vastness of the cosmos. Sunset and sunrise are not only visual phenomena, but also moments of emotional connection. They invite us to pause, to contemplate, and to appreciate the beauty that surrounds us. Sometimes, a simple glance at the sky can make us feel small in the vastness of the universe, but also part of something much larger. And if we think about the future, about advances in science and technology, it becomes fascinating to imagine how these phenomena have influenced space exploration. The search for exoplanets and the understanding of their atmospheres begins with the study of how light interacts with different atmospheric compositions. Thus, what we see in the sky could be an indication of what lies beyond our planet. The colours of sunrise and sunset teach us about science, but they also offer an opportunity for reflection. They remind us that, although life can often be chaotic and full of uncertainties, the Earth's natural cycles continue, providing us with moments of beauty and peace. So the next time you enjoy a sunset, let those colours inspire you and connect you with the world around you. In essence, the magic of sunset and sunrise is a phenomenon that goes beyond science. It's a reminder that the universe is constantly changing, and although we sometimes feel lost in the darkness, there is always a new dawn waiting. When observing the sky, we not only see colours but stories, discoveries, and a deep connection with the cosmos. So, go out and enjoy this natural spectacle. Why is space so dark even when there are millions of stars shining? This is a mystery that has intrigued scientists and curious minds alike. The answer lies in the absence of atmosphere in space. Unlike Earth, where the atmosphere acts as a filter that scatters light, outer space lacks this protective layer. It's as if we were in a completely dark room, where only a few lights flicker in the distance. On our planet, the atmosphere is composed of gases that interact with sunlight. When sunlight comes into contact with these particles, it scatters in different directions. This scattering is what gives colour to the sky during the day. But what happens in space? Without an atmosphere, light travels in a straight line, and although there are many stars, there is nothing to scatter it. That's why the background of space is perceived as a deep and mysterious black. Often, it is thought that space should be bright, especially considering the number of stars there are. However, here arises an intriguing question. If there are so many stars, why don't we see a sky full of light? Imagine a sea of lights extending far and wide, but what we see is a dark void. This is because the light from the stars is scattered so far that it reaches us very faintly. In space, light has no obstacles to stop it, and that makes it dilute into the vastness. Now let's think about an interesting phenomenon called Olber's paradox. If the universe is infinite and has an infinite number of stars, why don't we see a bright sky in every direction? The answer lies in the fact that the universe is not only vast but also expanding. This means that some stars are so far away that their light has not yet reached us. In addition, there are stars that have gone out and whose light no longer exists. The combination of these factors contributes to keeping space dark. But going back to the Earth's atmosphere, what role does it really play in the perception of colour? On Earth, when we look at the sky, sunlight interacts with the tiny particles of air, creating that beautiful blue we all know. However, when looking into space from Earth, we do not see this interaction. The vacuum of space does not have those particles that scatter light, resulting in the darkness we perceive. Now imagine you're in a high place, like a hill or a mountain. From there you can see the horizon much further and more clearly. In space, that feeling of clarity intensifies, as there is no atmosphere to filter the light. This means that the stars we see are just a small fraction of what really exists. But what does space look like from an astronaut's perspective? They see a deep black, interrupted only by the brightness of the stars. It's an impressive sight, but it can also be daunting. The solitude of space is palpable. As we delve into the darkness of space, the perception of light changes. The closer stars seem brighter, while the farther ones can be almost imperceptible. The light we see is the result of millions of years of travel through the vacuum. Each star we observe is like a time capsule, showing us what the universe was like at the time its light was emitted. Moreover, the lack of atmosphere in space means there is no scattering of colours. On Earth, the sky can display a palette of colours thanks to the interaction of light with the atmosphere. But in space, light behaves differently. Stars emit light in various colours, but when it reaches us, that light is presented in a purer tone without the influence of the atmosphere. The darkness of space is not only a visual phenomenon, but also has implications for physics and astronomy. Scientists use this darkness to study the properties of light and how it behaves in different conditions. Without the interference of the atmosphere, they can observe phenomena that would otherwise be invisible. This allows us to better understand the universe and its evolution. In the search for life on other planets, this understanding of light and the darkness of space plays a crucial role. Astronomers look for exoplanets that may have atmospheres similar to ours, as this could affect how we see their light. The darkness of space, therefore, is more than just a void. It is a space full of possibilities and discoveries. Finally, what does the darkness of space mean to us as human beings? It reminds us of our small but significant existence in a vast and constantly expanding universe. The darkness invites us to reflect on our place in the cosmos and to wonder what lies beyond. So, on every starry night when we look up, let's remember that the deep black of space is just a canvas on which the distant lights of the stars are drawn. It's a reminder that, although we are small, our questions and curiosities can illuminate even the darkest corner of the universe. Have you ever looked up at the night sky and wondered why it's so dark? The darkness of space is a fascinating phenomenon that leads us to explore the depths of the universe and the nature of light itself. To understand why space is black, we need to consider a fundamental aspect: the Earth's atmosphere and its absence beyond our planet. The Earth's atmosphere acts as a filter that transforms sunlight before it reaches our eyes. However, as we move away from Earth and venture into the vacuum of space, we encounter an almost total absence of matter. What does this mean for the light that comes from stars and other celestial bodies? In space, light travels unobstructed, allowing its pure essence to manifest. But it also means there is nothing to scatter or diffuse that light. This is the main reason why space is perceived as black. Imagine you're in a lit room where light bounces and scatters off the walls, creating a bright and cozy atmosphere. Now think about what happens when you close a door and turn off the light. Darkness takes over the space, as there is nothing to reflect the light. Outer space is like that dark room, but on a much larger scale. Without an atmosphere to scatter light, the result is a deep and dark vacuum. The expansion of the universe also plays a crucial role in this darkness. The universe is not only expanding, but it's doing so at a surprising speed. This phenomenon causes the light from distant stars to shift towards red, an effect known as redshift. As the stars move away, their light stretches, which affects their visibility. The further away a star is, the fainter it appears, and as it moves away, it becomes increasingly difficult to see. This effect not only contributes to the darkness of space, but also gives us clues about the nature of the universe. Reflecting on the light from stars, it's interesting to consider how its journey through space can be compared to a runner in a long race. Just like a runner moving away from the finish line, starlight has to travel vast distances before reaching our eyes. On this journey, it may encounter different obstacles, but in the vacuum of space, these obstacles are virtually non-existent. Therefore, light can travel freely, but its distance and the effect of the universe's expansion affect its intensity and colour. Our perception of black space is also influenced by the way humans perceive colour. Our eyes are adapted to perceive light in a specific range of wavelengths, which translates into the colours we know. However, in the vast ocean of space, the light that reaches us from the stars can be so faint that it gets lost in the immensity of black. This leads to the question, why do some stars shine brighter than others? The answer lies in the amount of light they emit and the distance they are from us. Moreover, the darkness of space has implications for how we explore the universe. The tools we use to observe the cosmos, such as telescopes, need to capture this faint light to reveal the secrets of the universe. But how do they do it? Telescopes are like large containers that trap light, allowing us to see what our eyes cannot. However, in such a dark environment, the light from stars must be amplified for us to appreciate their beauty. But not everything is darkness in space. Amidst that vast black, there is an abundance of celestial bodies that shine brightly, like planets and stars. The light they emit compensates for the immensity of the vacuum, creating a visual spectacle that invites us to look up at night. However, the light from these bodies is also affected by distance and the expansion of the universe, meaning not all stars shine with the same intensity in our sky. The lack of an atmosphere in space also means there are no conditions to generate optical phenomena like clouds, rainbows, or halos, which often decorate our earthly sky. In space, light does not scatter or refract, contributing to the perception of a completely black environment. This leads us to wonder, what if there were atmospheres on other planets? Would we see a sky of vibrant colours, or would it still be black? Meanwhile, the darkness of space is not just a void, but also the backdrop where the stories of galaxies, planets, and stars unfold. Each flash of light we see is the echo of past events, a window to what was, but no longer is. Light travels through time and space, taking us on a journey that transcends our existence. Finally, the darkness of space invites us to reflect on our place in the universe. It reminds us that, although we are a small part of this vast cosmos, each star we shine is a beacon of hope, proof that light always finds its way, even in the midst of darkness. So the next time you look at the night sky, remember that darkness is not just the absence of light, but a reminder of the wonder and immensity of the universe that surrounds us. The light from stars is like a whisper from the past reaching us through the vast ocean of space. But how is it possible that we can see these twinkling lights thousands of light years away? The answer lies in the journey that this light undertakes to reach us. Each star, from the brightest to the faintest, emits its light in all directions, and this light is part of the history of the universe. But what lies behind the light we see? When we observe the night sky, what we perceive is not just light, it is also a tale of distance and time. The light from the stars we see today may have originated millions of years ago. So when we look at the stars, we are actually seeing what the universe was like in the past. But what makes some stars more visible than others? The answer lies in two fundamental factors: luminosity and distance. The luminosity of a star refers to the total amount of light it emits. Some stars are true giants, shining with an intensity that can rival thousands of suns together. Others, on the other hand, are smaller and less bright, like tiny fireflies in the darkness of the sky. However, not everything comes down to luminosity. Distance plays a crucial role too. A very bright star that is a great distance away may seem less intense than a weaker star that is much closer. It's like having two headlights. One may be more powerful, but if the other is just a few meters away from you, you'll see it shine more intensely. In addition, the light from stars does not travel in a straight line, but is affected by the gravity of other celestial bodies. This phenomenon, known as gravitational lensing, can magnify or distort the light from distant stars. Imagine you're looking through a glass of water. The light that passes through the water bends, and in doing so can make the images behind the glass appear distorted. The same happens with the light from stars when it passes near a massive object in space, like a black hole or a galaxy. As the light from stars travels through space, it also encounters dust and gas, which can affect its color and brightness. This cosmic dust acts as a filter, attenuating and changing the characteristics of the light that finally reaches our eyes. Thus, when observing a star, we are seeing not only its original light, but also how that light has been altered on its journey through the universe. On this journey, the light from stars can also lose energy. When this happens, the light can change colour, shifting towards longer wavelengths. This phenomenon is known as redshift. So if you've ever seen a star that seems to have a warmer or reddish tone, it could be a sign that it's very far away. It's as if the light is trying to tell us I've travelled a long way. But what about the stars we don't see? Many stars are not visible to the eye due to their distance or the light surrounding them. However, telescopes have allowed astronomers to see much further than our eyes can capture. With the help of these tools, it has been discovered that the universe is full of stars, many of which are invisible to us. This vast ocean of stars is like a huge cosmic puzzle, where each piece tells a unique story. In the night sky, we can also see constellations, which are groupings of stars that form patterns. But interestingly, even though these stars seem to be together, they can actually be at different distances from us. The light from these constellations has travelled different paths and often originated at different times. So when we see a constellation, we are looking at a mosaic of lights that, although grouped in our view, may not be related in space. As we delve deeper into the cosmos, we discover that the light from stars also contains information about their composition. Each star has a spectrum, which is like its fingerprint. This spectrum is formed when the light from the star passes through a prism, separating into different colours. By analysing these colours, scientists can determine what elements the star is composed of. It's as if each star is sending a message through its light, revealing secrets about its origin and life. The light from stars is also crucial to understanding the evolution of the universe. By studying how stars shine and fade, astronomers can learn about the history of galaxy formation and the life of elements. Each explosion of a supernova, for example, is a brilliant event that sends waves of light and energy through space, enriching the interstellar medium with new elements that will eventually form new stars and planets. We cannot forget that the light from stars has also inspired humanity. Since time immemorial, stars have served as guides for navigators, symbols of myths and legends, and have been the subject of study and admiration. The quest to understand what they are and how they work has led many to become astronomers and scientists. Curiosity about starlight is an innate drive that connects us with the universe. So, the next time you look up on a clear night, remember that each star shining in the sky is a window to the past, a story of light travelling through time and space. Each flash, each flicker is a reminder that the universe is a vast place full of mysteries, and that the light from stars invites us to keep exploring and discovering. The light we see is not just a visual phenomenon, it is a journey, a tale of all that has existed, and a reminder of our place in the vastness of the cosmos. What happens when you look up at the sky on a starry night and realize that some stars shine brighter than others? That difference in brightness is just one of the many wonders the night sky presents us with. However, there is something we often overlook: light pollution. This phenomenon, which may seem like a technical term, affects our experience of the sky and, consequently, our connection with the universe. Light pollution refers to the artificial light that illuminates our cities and towns at night. This light, which comes from street lamps, illuminated signs, and lit windows, can be so bright that it outshines the stars. Imagine the sky as a black canvas, filled with bright dots. Now, if you start throwing white paint on that canvas, what will happen? Indeed, the brightness of the paint will cover many of those dots, and that is precisely what light pollution does. Why should you be concerned about light pollution? Think about this. Every time you look up and see a sky full of stars, you are looking into the past. The light from stars can take thousands or even millions of years to reach us. However, if the glow of city lights is too strong, you may not be able to see those stars that have been travelling towards you for so long. Isn't it fascinating and a bit sad to think that you could be missing such an ancient connection with the universe? Astronomers have noticed that in recent decades the number of visible stars has decreased in many urban areas. In places with a lot of light pollution, like big cities, only a few dozen stars can be seen with the eye. In contrast, in rural areas or places far from civilization, the number can rise to thousands. This leads us to wonder, what would the sky look like if we could eliminate all that artificial light? Sometimes light pollution can also affect our health. Constant exposure to bright lights at night can alter our sleep patterns and affect our overall well-being. Studies suggest that artificial light can interfere with the production of melatonin, the hormone that regulates sleep. So the next time you stay up late, maybe you should consider whether that bright light coming through the window is interfering with your rest. In addition to its impact on health and star visibility, light pollution also has effects on wildlife and plants. Many animals, including insects, birds, and sea turtles, depend on the natural light of the moon and stars for orientation. Artificial light can confuse them and alter their natural behaviors. For example, some newborn turtles head towards the glow of the ocean, but if there is too much light on the coast, they may end up heading towards the road instead of the sea. Isn't it surprising how something as simple as a light bulb can have such profound consequences on the ecosystem? To mitigate light pollution, solutions are being implemented in many cities. Some have started to use low brightness lighting, or install lights that direct light downwards instead of upwards. Imagine a scenario where the streets are lit in a way that we can see what we need without obscuring the sky. This would not only preserve the awe of the night, but could also benefit wildlife and improve our health. However, the fight against light pollution is not just a matter of technology or urban planning. It is also a matter of awareness. Each of us can contribute to the solution. Turning off unnecessary lights at home, using opaque curtains, and opting for low-energy lamps are just some of the ways we can help. How about every time you go out to observe the stars, you commit to making a small change in your home? The next time you look up and the sky's clear, remember that there are stories and wonders hidden among the stars that could be obscured by artificial light. With a little effort, we could reclaim the splendor of the night sky, a gift that connects us with the universe and our own history. Light pollution not only affects what we see, but also what we feel. The awe we feel when looking up and contemplating the vastness of the universe is an experience that everyone should have. The beauty of a starry sky is a reminder of our own insignificance and the grandeur of what surrounds us. By taking care of our environment and being aware of the light we generate, we not only improve our quality of life, but also preserve the magic of the night sky for future generations. So every time you face a partially star-covered sky, remember that, although light pollution can darken our view, there are always ways to illuminate our path to a clearer and brighter sky. In this quest for a starry sky, we not only connect with the stars, but also with the very essence of what it means to be human. Curiosity, awe, and the desire to explore the unknown. What happens when sunlight meets the Earth's atmosphere? This interaction leads to fascinating optical phenomena that, although often overlooked, are a fundamental part of our daily experience. From a simple rainbow to spectacular halos around the sun, the atmosphere becomes a canvas that transforms light into a natural work of art. But how does this happen? First, let's think about the rainbow. Did you know that it's not just a visual phenomenon, but a spectacle of refraction and dispersion? When sunlight enters a water droplet, like those suspended in the air after a rain, it bends and separates into its different colours. This process is similar to what happens when light passes through a prism. So, every time you see a rainbow, you're witnessing a symphony of colours, a dance of light in its purest form. Now let's move on to another phenomenon. Halos. These circles of light that sometimes appear around the sun or the moon are equally impressive. They form when sunlight refracts through ice crystals in the atmosphere. Imagine these crystals as tiny prisms in the sky, breaking light into bright colours and creating a magical halo. The next time you see one, remember that it's a reminder of the hidden beauty in science. What about reflections? The atmosphere can also act as a giant mirror. When light enters a body of water, like a calm lake, it reflects and creates images on the surface. But if we look up at the sky, we can see reflections of light in the clouds, creating a constantly changing visual spectacle. This play of light and shadows is a reminder that the atmosphere is always active, transforming light in unexpected ways. Fog is another phenomenon that deserves attention. When humidity builds up in the air, it can create a veil that softens the light passing through it. On cloudy or foggy days, the light seems softer and diffused, giving an ethereal aspect to our surroundings. This phenomenon not only affects our vision, but also influences our perception of colour. At these times, the world seems wrapped in a palette of muted and mysterious tones. On the other end, a clear sky can offer dazzling clarity. On those days, colours seem more vibrant and details sharper. The clean atmosphere allows sunlight to shine in all its splendour, making sunny days perfect for going out and enjoying nature. But what happens when the atmosphere is polluted? Air pollution can distort light, creating a grey and opaque sky, which can affect our mood and our perception of the world. Speaking of pollution, have you ever wondered why city lights seem brighter on cloudy nights? The haze and humidity in the air act as a diffuser, causing the light to spread and shine more intensely. However, this can also hide the stars, robbing us of the opportunity to see the vast universe that surrounds us. This is one of the ironies of modern life. The more artificial light we have, the harder it is to see the natural glow of the sky. The atmosphere not only affects how we perceive light, but it can also influence our moods. Sunlight has a powerful effect on our well-being. Exposure to natural light can improve our mood and increase our energy levels. This is because light activates the production of serotonin in our brain, the happiness hormone. When the sky's clear and sunny, we feel happier and more motivated. In contrast, on dark and cloudy days, it's common to feel more down. Optical phenomena are not just curiosities, they also have a practical impact. For example, pilots and navigators use phenomena like refraction to determine their position and orient themselves in the sky. Understanding how light works in the atmosphere is crucial for many disciplines, from meteorology to astronomy. The science behind these phenomena helps us predict the weather and better understand our environment. And what about the northern lights? These spectacular lights that shine in the night sky are the result of the interaction between solar wind and the Earth's atmosphere. When the sun's charged particles collide with gases in our atmosphere, an explosion of colours that dance in the sky is produced. The auroras are a reminder that light is not only found in our immediate environment, but is also part of a broader cosmic system. Human curiosity also plays a role in our appreciation of these phenomena. Since ancient times, cultures have looked at the sky and marvelled at the colours and lights they observed. Myths and legends often intertwine with science, creating a rich narrative that enriches our understanding of the world. Science and culture intertwine, making the exploration of these phenomena even more fascinating. In summary, the Earth's atmosphere is a stage on which light plays a starring role. From rainbows and halos to the northern lights, each optical phenomenon invites us to look up and marvel. The next time you observe the sky, remember that you're not just seeing a vast blue or starry space, but also a spectacle of light and colour that tells stories of nature and science. These visual experiences are an invitation to explore and better understand the world around us, a constant reminder that science can be as beautiful as it is intriguing. Have you ever noticed how the colour of the sky changes in different parts of the world? The perception of the sky's colour is not just a matter of aesthetics, but is also deeply influenced by altitude. As we ascend in the Earth's atmosphere, the way light interacts with the air around us changes, leading to surprisingly different visual experiences. First, let's think of the atmosphere as a huge layer of air surrounding us. This layer is not uniform. It is composed of different gases and particles that affect how we see colour. At sea level, the atmosphere is denser, meaning there are more air molecules and dust in the path of sunlight. This can make the sky appear lighter and at times even more dull. But what happens when we ascend to higher altitudes? Imagine you are on a tall mountain, where the air is thinner and less dense. At these heights, sunlight has fewer obstacles to overcome. Therefore, the intensity of the sky's blue colour may appear more vibrant and deeper. This phenomenon is due to there being less light scattering, allowing the blue hues to stand out more. Now, why blue? Blue is the colour that scatters the most in our atmosphere. The higher we are, the clearer and deeper the sky appears, On mountain peaks, the sky can appear almost electric blue, as if it were screaming its beauty. This is because the scarce air does not scatter light in the same way as the dense air at sea level. So, in a sense, altitude not only gives us a wider view of the world, but also offers us a richer colour palette. In addition, the clarity of the air at high altitudes also means we can see further. Pollution and humidity tend to decrease as we ascend, allowing light to travel unobstructed. This not only affects the colour of the sky, but also allows stars and other celestial objects to be more visible. On a clear night at the top of a mountain, you may be amazed by the number of stars you can see, many more than you could observe from a lit city. But what happens in places where the altitude is extreme, like in the Himalayas? Here the atmosphere is so thin that sunlight not only scatters less, but can also appear more intense and whiter. These intensity can be dazzling and in some cases even dangerous. That's why mountaineers often wear sunglasses to protect their eyes from intense solar radiation, which can cause skin burns and eye damage. As we ascend, we may also notice that the sky can appear darker compared to the ground. This contrast is due to the fewer particles in the air reflecting light. On summits, the sky can appear almost black during the day, which further highlights the deep blue surrounding it. This visual experience can be almost surreal, as if you were in a place where nature has decided to intensify the colours. Altitude can also influence how we experience other atmospheric phenomena. For example, at high altitudes, rainbows can appear sharper and more vibrant. This is because there is less humidity in the air, allowing sunlight to split and refract more efficiently. On a mountain, you may find rainbows that appear more vivid, as if they were painted with bright watercolours. The experience of being in the high mountains not only offers a change in the colour palette, but can also influence our mood. The beauty of the landscape, combined with an intense blue sky, can evoke feelings of awe and peace. It can be a reminder of how small we are compared to the vastness of the universe, and how light and colour play a vital role in our perception of that universe. Cultures around the world have recognised the influence of altitude on the perception of the sky. In many traditions, mountains are seen as sacred places, where the sky feels closer and the connection with the divine seems more palpable. Altitude not only affects what we see, but also how we feel and how we interpret our place in the world. Finally, the experience of observing the sky from different heights can be an opportunity to reflect on our relationship with the environment. It reminds us that although we are anchored to the earth, there is always a larger, bluer world waiting for us. The next time you look up, whether from the top of a mountain or from the comfort of your home, consider how altitude and atmosphere influence what you see and how it makes you feel. The science behind these phenomena is not only fascinating, but also enriches our connection with the sky and the space around us. Have you ever stopped to observe how the planets and the moon seem to play on the vast canvas of the night sky? The way these celestial bodies influence our perception of the sky is fascinating and deserves deeper exploration. The planets, with their particular brightness and trajectories, invite us to look up, while the moon, that silvery beacon, transforms our nights in ways we often do not fully understand. The moon, for its part, not only illuminates the darkness, but also plays a crucial role in how we perceive the colour of the sky. When it is full, its light can reflect off the clouds and give them a warmer, almost golden hue. But what happens when it is in its new phase, when we barely see it? At those times, the sky seems even darker, and the stars shine with an intensity that can sometimes be overwhelming. This variation in the perception of the night sky is closely related to the amount of light the moon reflects. As for the planets, each one has its own character. Venus, known as the morning star or the evening star, stands out for its brightness. This brightness is no accident. It is due to its dense atmosphere, which effectively reflects sunlight. However, when we look towards Mars, we notice that its reddish colour stands out in the firmament. This phenomenon is the result of its iron oxide-rich surface, which gives it that characteristic tone. The sunlight bouncing off these celestial bodies reaches our eyes, giving us a clue about their composition and distance. But what about Jupiter and Saturn? These gas giants have a commanding presence in the sky. Jupiter, with its cloud bands and its great red spot, reminds us of the complexity of the universe. Saturn, with its majestic rings, intrigues us with its beauty. Both planets are so distant that their light takes years to reach us. However, despite this distance, their light becomes a bridge that connects our perception with the vastness of the cosmos. The influence of the moon and the planets is not limited to the light they emit. Their gravity also affects the Earth, resulting in phenomena such as tides. These tides are a physical manifestation of the interaction between the moon and the Earth, and are a reminder that everything in the universe is interconnected. But what is the relationship between these tides and the colour of the sky we see? The answer lies in the Earth's atmosphere, which acts as a filter for the light coming from these celestial bodies. As we move into the night, the position of the moon and the planets changes, and with it, our perception of the sky. The moon's light can fade and the sky becomes darker, allowing the fainter stars to become visible. In subtle contrasts, the planets shine like jewels on a dark mantle, while the constellations tell ancient stories that have fascinated humanity for millennia. The sky is not only a visual spectacle, it is also a canvas of emotions and reflections. The way we respond to the presence of the moon and the planets can evoke feelings of awe, nostalgia, or even introspection. Why are we so drawn to these celestial bodies? Perhaps it is because they represent the unknown, the mysterious, what we have not yet fully understood. Cultures around the world have found meaning in the moon and the planets, weaving myths and legends around them. From the ancient Greeks to the Mesoamerican civilizations, the moon has been a symbol of fertility, change, and time. This cultural connection adds another layer to our perception of the sky, reminding us that we not only observe the cosmos but also are part of it. With each lunar phase, our perception of the sky changes, and so do our experiences. The full moon can inspire romance, while a new moon invites us to reflection and introspection. The planets, on the other hand, remind us that there is much more beyond our atmosphere. When we look towards them, we not only see light, we see the history of our solar system, a narrative that has unfolded over billions of years. The next time you look at the night sky, take a moment to consider not only the stars, but also the influence of the moon and the planets on your perception of colour and light. Each flash and each shadow tell a story that connects us with the universe in ways we sometimes do not fully understand. At the end of the day, the sky's a mirror of our own experiences and emotions, and its splendour reminds us of how small we are compared to the vastness of the cosmos. What would happen if I told you that the origin of the universe, an event as colossal as the Big Bang, not only created everything we see today, but also influenced the light and colour that surrounds us? The story of the Big Bang is fascinating and full of mysteries that we are still trying to unravel. Why, after so much time, does it still matter to us? The answer is simple. Understanding the Big Bang is understanding how we came to be and why the sky has such astonishing colours. Let's imagine for a moment that the universe is like a big balloon. When we inflate a balloon, the air expands and the material stretches. The same happened with the universe. At first, it was concentrated in an incredibly small, dense and hot point. In an instant, everything expanded. This expansion not only created space, it also released an immense amount of energy in the form of light. But what kind of light was that? When released, the light from the Big Bang was extremely hot, full of energy, and as the universe expanded, that energy began to cool down. Over time, the light went from being a bright whitish colour to a warmer tone, similar to that of a young star. This is where the relationship between light and colour comes into play. How does this affect what we see today? The light that reaches us from the ancient events of the universe has travelled billions of years. Can you imagine what that means? Every time we look at the sky, we're looking at a window into the past. The stars we see shining at night might have ceased to exist long ago, but their light is still travelling towards us. This light has a story to tell, and that story is intimately linked to the expansion of the universe. One of the most astonishing phenomena that arose from this expansion is redshift. What does this imply? As galaxies move away from us, the light they emit stretches. This stretching causes the light to shift towards longer wavelengths, which translates into redder colours. In this way, the universe is not only expanding, but it's also changing the colour of the light we receive. Now, if the universe keeps expanding, does that mean we will always be in the dark? Not necessarily. Although space is vast and for the most part dark, the light from the Big Bang and the stars still reaches us. However, the expansion also means that some of those stars are so far away that their light will never reach us. How ironic, right? We live in a universe full of light, but at the same time in one that is constantly moving away. The light from the Big Bang also gives us a clue about how the elements that make up our world were formed. In the first moments after the explosion, the first atoms were formed, mainly hydrogen and helium. These elements in turn grouped together to form the stars and galaxies we see today. Every time we look at the sky, we're observing the legacy of that primordial explosion. But can we see the Big Bang? The answer is no, but we can see it through the cosmic background radiation, a form of light that fills the universe. This radiation is an echo of the Big Bang, and although it is very faint, we can detect it. This gives us an idea of what the universe was like in its earliest moments just after creation. So, how does all this relate to the colours we see in the sky? Understanding the Big Bang helps us understand that the light travelling through the universe is not just a physical phenomenon, it is a story in itself. Every colour, every flash of light has a story to tell about the evolution of the universe. When we look at the sky, we are actually looking at the traces left by these cosmic events. Moreover, the Big Bang invites us to reflect on the very nature of light. What is light? It is energy, it is information, it is a link that connects us with the past. Through light, we not only see colours and shapes, we also perceive the history of the universe. And this connection reminds us that we are part of something much bigger. What if I told you that understanding the Big Bang and the nature of light can also have implications in our daily life? The way we perceive light and colour affects our mood, our emotions, and our decisions. So the next time you look at the sky, remember that you're not only seeing a physical phenomenon, but also a reflection of the history of the universe. Finally, the expansion of the universe and the legacy of the Big Bang show us that we are in constant motion. Just like the universe, our perceptions, thoughts, and emotions are evolving. So, when you stop to observe the blue sky or the darkness of space, think about how light and colour connect us with the history of everything that surrounds us. And remember, the universe is a place full of wonders waiting to be discovered. Einstein's theory of relativity is one of the fundamental pillars of modern physics, and its relationship with light leads us to explore fascinating concepts that often seem taken from a science fiction novel. Did you know that light can behave in ways that defy our most basic intuition? For example, the speed of light is constant in a vacuum, which means that no matter how fast you move, light will always travel at the same speed. But what happens if you approach that speed? This is where relativity comes into play. Imagine that you're on a train travelling almost at the speed of light and you look out the window. What you will see will not be the same as the observer at the station. For you, the outside world will seem compressed and the colours will be altered. This phenomenon is known as blue and red shift, where the light from moving objects is compressed or stretched, depending on their direction of movement relative to you. Thus, if an object moves away, its light shifts to longer wavelengths, resulting in a shift towards red. Conversely, if it approaches, the light shifts to shorter wavelengths, giving us a more bluish tone. This concept is not just a physics magic trick. It has real implications in how we perceive the universe. Astronomers use redshift to determine if galaxies are moving away from us. The redder an object appears, the further away it is, and this has become an essential tool for understanding the expansion of the universe. But what exactly causes this expansion? The answer lies in the Big Bang, a primordial event that not only created space but also set the rules for light. At the time of the Big Bang, the universe was an extremely hot and dense place. As it expanded, it cooled, and light began to travel through this new space. However, it was not until the universe cooled enough that atoms could form and allow light to travel freely. This means that when we look at the sky, we are seeing light that has travelled for billions of years. Isn't it amazing to think that by observing the stars we are looking back in time? Relativity also tells us that time is not a universal constant. It changes depending on the speed at which you move and the gravity you experience. This leads to an intriguing question. What would happen if we could travel at a speed close to that of light? In theory, time would slow down for the traveller compared to those who stay on Earth. This time, dilation has profound implications not only for physics, but also for our understanding of life itself. As we reflect on light and relativity, we must also consider the role that gravity plays. Einstein proposed that gravity is not just a force, but a curvature of space-time. This means that massive objects, like planets and stars, can affect the path of light. When the light from a star passes near a massive object, its trajectory curves. This phenomenon, known as gravitational lensing, allows astronomers to observe objects that would otherwise be invisible. Isn't it amazing to think that gravity can bend light? Now, how does all this relate to our daily life? Modern technology, like GPS, relies on the theory of relativity. The satellites orbiting Earth have to take into account both time dilation and space curvature to provide accurate information. Without relativity, the directions we follow daily would be full of errors. So in a way, Einstein's theory helps us not to get lost in our own cities. When we talk about light and relativity, we are also touching on issues of perception. Our eyes are sensitive to a small fraction of the electromagnetic spectrum, which means we only see a part of the light that surrounds us. But what about the wavelengths we can't see? Ultraviolet and infrared rays are invisible to us, but they have significant effects on our environment. This leads us to wonder, what else could be happening in the universe that we simply cannot perceive? At its core, Einstein's relativity invites us to question what we know about space and time. It shows us that the universe is a much stranger and more wonderful place than we could imagine. Every time we look at the sky, we see more than just stars. We see stories of light that have traveled through time and space, leading us to reflect on our place in the cosmos. So the next time you watch a sunset or look at the stars, remember that the light you see is not just a physical phenomenon, it's a journey through time and space, full of mysteries we are still trying to unravel. Relativity not only changes our understanding of light, but it also transforms our perception of the universe, reminding us that there is always more to discover, more to explore, and more questions to ask. What would happen if I told you that some of the most fascinating concepts about light and colour have been discovered through truly ingenious experiments? Throughout history, human curiosity has led scientists to ask intriguing questions about how we perceive the world around us. How is it that a simple ray of light can reveal so much about the universe? In this section, we will explore some of the historical experiments that have illuminated our understanding of light and colour in the atmosphere. One of the first to make a significant contribution was Isaac Newton, a name that resonates in the history of science. In the 17th century, Newton came across a glass prism and decided to conduct an experiment that would change our perception of light forever. By directing a beam of white light through the prism, he was amazed to see it break down into a spectrum of colours. Can you imagine being the first to discover that white light is not just a uniform mixture, but a kaleidoscope of colours. This finding was not only a breakthrough in the field of optics, but also laid the groundwork for understanding how colour forms in our atmosphere. But what about sunlight when it reaches Earth? In the 19th century, a scientist named John Tyndall decided to investigate how light behaves when passing through the atmosphere. Tyndall conducted experiments that demonstrated that particles in the air could scatter light. This leads us to an intriguing question. Why is the sky blue and not another colour? His work was fundamental in understanding Rayleigh scattering, the phenomenon that explains why we see the sky in blue tones during the day. Tyndall's observations did not stop there. He also noticed that at sunset, sunlight has to pass through more atmosphere, which causes warm colours like red and orange to be more prominent. Imagine being there, watching how sunlight transforms as it hides on the horizon. His discoveries were crucial in connecting science with our everyday experiences. As we move forward in time, we come to the 20th century, where Albert Einstein challenged our understanding of light with his theory of relativity. Einstein wondered, what if light not only travels through space, but is also related to time and speed? His revolutionary ideas not only changed physics, but also led us to think about how we perceive the universe. Light became a symbol of the connection between space and time, a concept that still intrigues us today. Science has come a long way since those days, and researchers continue to explore the properties of light. Today, scientists use sophisticated instruments to measure and analyze light in ways that Newton and Tyndall could barely imagine. Have you ever wondered what else they can discover about the colour of the sky and light in space? The answer to that question leads us to the fascinating search for exoplanets and the possibility of life on other worlds. Historical experiments not only teach us about light and colour, but also reflect human curiosity. The questions that arise from observation and exploration lead us to discover amazing truths about the universe. In this sense, each experiment is like a piece of a cosmic puzzle, where each discovery opens the door to new questions. The interaction between science and philosophy is also notable. How have these discoveries influenced our way of seeing the world? Throughout history, light has been a symbol of knowledge and revelation. Every time we look at the sky, we remember that there is a rich history behind what we see, a story full of experiments, discoveries, and the relentless curiosity of humanity. Today, the study of light and colour remains a vibrant field of research. Scientists continue to challenge preconceived notions and explore new frontiers in physics, astronomy, and optics. Who knows what new wonders the future holds in our understanding of light? The history of the experiments that have shaped our ideas about light and colour is ultimately a testament to human ingenuity. Thus, reflecting on historical experiments, we realize that they have not only been important for science, but have also influenced the way we perceive the world. Every time we look at the sky and see its colour, we remember that behind that appearance there is a rich and complex story, woven by the threads of curiosity and discovery. Light, in its essence, is much more than a physical phenomenon. It is a reminder of humanity's endless journey to understand its place in the universe. The science behind the colours of the sky is a fascinating journey, that invites us to explore how scientists have unraveled the mysteries that surround us. How is it possible that the same sky can have so many different shades? From the bright blue of the day to the intense reds and oranges of dawn and dusk, the sky is a constantly changing canvas. But what's behind all this? To understand it, we must first immerse ourselves in the fascinating world of light. Imagine that light is like a rainbow, a spectrum of colours that unfolds before us. Each colour has its own wavelength, and this variation is essential to understand why we see the sky in different colours under different circumstances. If a wavelength is shorter, like blue, it scatters more easily in the atmosphere. On the other hand, longer wavelengths, like red, travel straighter and do not scatter as much. Scientists have conducted numerous experiments to analyse this phenomenon. One of the most famous is the scattering experiment conducted by British physicist Lord Rayleigh. By studying how sunlight interacts with the tiny particles in the atmosphere, he discovered that blue is the colour that scatters the most. But what is the impact of this finding on our daily perception? Every time we look at the sky, we are seeing how the tiny particles of air play with the light, creating the beautiful spectacle we admire. The work of these scientists is not limited to observation. They have also developed mathematical models to predict how light will behave under different atmospheric conditions. Can you imagine being able to predict the colour of the sky before leaving home? Thanks to these models, we can better understand phenomena like sunset, when sunlight passes through a larger amount of atmosphere and takes on warm colours. In addition, scientists have used telescopes and other instruments to study the light from stars and how it travels through space. By observing different stars, they have been able to identify their colours and from there deduce their temperature and chemical composition. It's as if the colour of a star tells us a story about its life and its environment. Each star has its own character, and the light it emits is a reflection of its essence. The research doesn't stop there. Scientists have also explored how factors like altitude and light pollution affect our perception of the sky's colour. Did you know that at higher altitudes, the sky can appear bluer? This is because there is less atmosphere to scatter the light. And in urban areas, light pollution makes many stars invisible, altering our experience of the night sky. For those who are dedicated to the science of colour, each day is a new opportunity to discover. There are colour analysts who study how changes in the atmosphere affect our perception. They use advanced tools to measure the intensity and spectrum of colours in the sky. Each observation is a step further towards understanding this phenomenon, and their findings can be applied in fields as diverse as meteorology and photography. An intriguing aspect of this science is its connection with human perception. Often, what we see is not just a matter of physics, but also how our brain interprets visual information. Research in neuroscience has shown that the way we perceive colours can vary from person to person. Have you ever argued with someone about whether the sky's bluer or greyer? This variability in perception is part of what makes the study of colour and light so captivating. Scientists have also conducted historical studies on the colour of the sky. In past times, philosophers and astronomers were already asking questions about light and colour. Their theories laid the groundwork for modern discoveries. The history of colour science is, in many ways, a story of the evolution of human thought. What has emerged from all this is an exciting field of study that continues to expand. The combination of advanced technology and human curiosity has led to incredible discoveries. Now, scientists can not only observe the sky, but also simulate it and predict its changes. Modern tools allow us to see beyond what our eyes can capture, revealing a world of colours and nuances that was previously invisible. The science of the sky and colours is a reminder that, even in the everyday, there are wonders to discover. Every time we look up, we are surrounded by science and beauty. What seems like a simple blue sky is, in reality, the result of a complex ballet of light, particles, and perception. As we continue to explore, each answer leads to new questions, and the sky always invites us to look with curiosity. So the next time you stop to contemplate the sky, remember that behind each colour there is a story that has been carefully unravelled by scientists over the centuries. The science of colour not only teaches us about the world around us, but also connects us with the endless pursuit of knowledge and understanding that defines humanity. The search for other worlds is a fascinating adventure that has captured the imagination of humanity for centuries. But how do we know what to look for when we gaze into the vast ocean of space? It all starts with light. Light not only allows us to see, but it also gives us clues about the composition and characteristics of the planets and stars that surround us. Every flash that reaches our eyes is a story waiting to be told, a message from the universe speaking to us in a language we can learn to interpret. Have you ever wondered why some planets seem brighter than others? The answer lies in how light interacts with them. Each planet reflects sunlight in a unique way, depending on its atmosphere, its surface, and its distance from our star. For example, Venus, with its dense atmosphere of sulfuric acid clouds, reflects a large amount of sunlight, making it one of the brightest objects in our sky. This brightness is not only spectacular, but it also indicates that there is more we can learn about its composition and climate. Colour also plays a crucial role in this search. When astronomers observe other planets, they analyse the light that is reflected off them. This is often done through a process called spectroscopy, where light is broken down into its different colours, revealing the fingerprint of the elements present in a planet's atmosphere. Imagine that each planet has its own colour code, a set of hues that tells us what gases make it up. For example, the presence of methane can indicate biological activity, which sparks enormous interest in the search for life. An intriguing topic is the search for exoplanets, which are those that orbit stars outside our solar system. These distant worlds are often difficult to detect, but light is our ally. When a planet passes in front of its star, it blocks a small fraction of light, which can be recorded by telescopes on Earth. This transit not only indicates that a planet is present, but it also allows us to calculate its size and its distance to the star. This technique has been fundamental in the discovery of thousands of exoplanets, expanding our understanding of the universe. As scientists advance in their search, they also face challenges. How do we know if an exoplanet is habitable? The answer lies in its location, at just the right distance from its star, in what is known as the habitable zone. Here, temperatures are suitable for water to exist in liquid form, an essential ingredient for life as we know it. But what if we find a planet that is similar to Earth but has a different atmosphere? The light that reaches us from that world can give us clues about its conditions, revealing whether there is water, carbon dioxide, or even oxygen. This search for exoplanets has also led us to question our own existence. Are we alone in the universe? Each new discovery of a planet in the habitable zone invites us to think about the possibility that other beings are looking up at the sky, wondering the same thing. The light that travels through the cosmos may be the key to answering that question. By understanding how light behaves in different environments, we can infer the conditions on other worlds. However, it's not all about searching for life. There is also great interest in understanding how planetary systems form. The light from young stars, for example, can give us information about how planets group and evolve. By observing how light scatters and filters through clouds of gas and dust, astronomers can reconstruct the processes that gave rise to our own planets. Technology has advanced by leaps and bounds. Space telescopes like the Hubble or the more recent James Webb allow us to look further and clearer than ever before. Imagine being able to see the light from a planet hundreds of light years away. These telescopes are like gateways to other worlds, capturing light that has travelled for centuries to reach us. With each new advancement, we get closer to answering questions that have persisted for millennia. However, the search is not without challenges. Light pollution on our own Earth can hinder our observations. When we look at the sky from a city full of lights, many stars are hidden. This phenomenon not only affects amateur astronomers, but it also raises questions about how our activities impact our ability to explore the universe. International collaboration is also crucial in this search. Scientists from around the world work together to analyze data and share discoveries. The light that is collected from different points on the planet is combined, creating a more complete picture of the universe. This cooperation is a reminder that, despite our differences, we all share a common interest in understanding the cosmos. As we delve deeper into the mystery of the universe, it becomes clear that light is more than just a simple physical phenomenon. It is a tool that allows us to explore, discover, and understand. Through light, we can glimpse not only other worlds, but also our place in the vast cosmos. The search for other worlds is a journey filled with wonders and surprises. Each star, each planet we discover, is a new opportunity to reflect on our existence and our future. The light that guides us is a beacon in the darkness, illuminating our path towards the unknown and reminding us that in the vast universe, there is always more to discover. What does it mean for us to look at the sky? Since time immemorial, the sky has been a source of inspiration and awe for humanity. But have you ever stopped to think about how our perception of the sky and space has shaped our cultures and philosophies? When we observe the vast firmament, we are not only contemplating a natural phenomenon, but we are also confronting profound questions about our place in the universe. The idea that the sky is blue during the day and dark at night has influenced the way we understand the very nature of existence. How is it possible that such a vast and seemingly empty space is full of meaning? Throughout the centuries, philosophers, scientists, and artists have attempted to capture the essence of this duality. The search for answers has generated myths, religions, and theories that try to explain our environment. Ancient cultures, for example, saw the sky as a reflection of the divine. In many civilizations, gods were represented as celestial bodies, and their presence in the sky provided a sense of order and purpose. Looking at the stars, they felt connected to something larger than themselves. But what happens when science begins to question these beliefs? The advent of modern astronomy opened a new chapter in our understanding of the cosmos. The relationship between science and philosophy has often been tense. Can science, with its rational and empirical approach, answer the existential questions that have plagued humanity? As scientists unravel the secrets of the universe, some wonder if we are losing something along the way. The poetry of the sky, the beauty of the stars, the mystery of the unknown, do they fade in the light of reason? The search for other worlds has also brought about a shift in our perspective. As astronomers discover exoplanets, the possibility of life elsewhere in the universe invites us to reconsider our uniqueness. What does it mean to be human in such a vast and diverse cosmos? This questioning leads us to reflect on our own identity and our impact on the planet. The contemplation of the night sky has inspired artists and thinkers to create masterpieces that capture the essence of what it means to look up. From Van Gogh's paintings to song lyrics that evoke the immensity of space, the sky has been a canvas for human creativity. In this sense, how do our perceptions of the sky influence our cultural expression? The darkness of space also raises questions about the meaning of emptiness. Is it truly dark, or can we simply not see what's there? This philosophical question becomes a mirror reflecting our own internal struggles. Darkness can be terrifying, but it can also be a space for reflection and self-knowledge. What do we discover about ourselves when we face the unknown? The concept of the expanding universe, with its infinite depth and mystery, challenges us to rethink our place in time and space. In a constantly changing universe, how can we find stability and meaning? This dilemma invites us to explore our own beliefs and values, and to consider how they intertwine with science and philosophy. Optical phenomena in the atmosphere, such as rainbows and halos, remind us that beauty is often at the intersection of science and poetry. These natural wonders are not only a spectacle for our eyes, but also teach us about the complexity of light and perception. How can we appreciate the science behind these phenomena without losing sight of their awe? As we delve into the digital age, light pollution has become a challenge to our connection with the sky. Artificial light has erased the constellations that once guided our ancestors. What have we lost by sacrificing the darkness of the night sky in favor of the light of progress? The answer to this question could be key to understanding our future as a species. Exploring the cosmos is not only about understanding the outer universe, but also about exploring our inner universe. Advances in science have led us to question our existence and our purpose. In this sense, the search for answers about the sky and space becomes a quest for self-knowledge. The relationship between science and spirituality also becomes evident. While science seeks to break down and understand the universe, spirituality often seeks connection and meaning. can these two approaches coexist? Perhaps the sky is a reminder that there is room for both perspectives. The perception of the sky and space has influenced the way we build our societies and understand our interactions. From navigation to religion, the way we see the sky has shaped human history. What does the future hold as we continue to explore the unknown? In the end, when we look up, we not only see a space filled with stars, but a reflection of our own curiosity, longings, and concerns. The sky, in all its majesty, invites us to keep questioning, exploring, and dreaming. So, what will the sky reveal the next time we look up? In this constant quest to understand the universe, perhaps we will discover more about ourselves than we ever imagined. Have you ever stopped to think about the vastness of space and how it influences our perception of the world? The relationship between the sky and the cosmos is a fascinating topic that invites us to reflect on our existence and our place in the universe. By understanding why the sky is blue and space is black, we embark on a journey that goes beyond science, touching on philosophical and cultural aspects that have accompanied humanity since time immemorial. The perception of the colour of the sky offers us a window into the complexity of the interactions between light and the atmosphere. Why does the blue seem so vivid during the day and transform into warm tones at dawn and dusk? This transformation of colours is a constant reminder that nature is a canvas in constant change, and that our observations are influenced by factors that we often do not see at first glance. Each nuance is the result of a dance between sunlight, the atmosphere, and our own vision. The darkness of space, in contrast, raises intriguing questions about solitude and infinity. If the universe is so vast and full of stars, why don't we see a bright sky all the time? This paradox is related to the expansion of the universe and the Doppler effect phenomenon, reminding us that not everything that exists is visible to our eyes. Darkness can be disturbing, but it's also a reminder that there is much more beyond what we perceive, and that there are mysteries to discover. As we explore the night sky, the light of the stars tells us stories of distant times and spaces. Each star we see has undergone a monumental journey to reach us, and its brightness is an echo of the cosmic processes happening in the vast universe. When we look up, we not only see a visual spectacle, but we also connect with the past, remembering that each bright point has its own story to tell. Light pollution is another factor that affects our perception. In a world where city lights often overshadow the beauty of the starry sky, we are forced to question our relationship with artificial light. What have we sacrificed in our pursuit of comfort and safety? Reflecting on this leads us to a greater appreciation of the darkness and silence of space, which can be a refuge for those seeking to contemplate the universe. Optical phenomena such as rainbows or halos are reminders that the atmosphere is a stage where light plays its own theatre. Every time we see a rainbow, we are witnessing a spectacle of nature that invites us to stop and marvel. This leads us to consider how these phenomena have influenced culture and mythology throughout history, becoming symbols of hope and transformation. Altitude also plays an important role in our perception of the colour of the sky. The higher we are, the clearer and more vivid our vision becomes. It's as if the sky offers us a new perspective, reminding us that there is much to discover if we dare to rise and see the world from another angle. This idea of rising can be applied not only to physics, but also to our personal and spiritual aspirations. The role of the planets and the moon in the night sky teaches us about the interconnection of all celestial bodies. Each planet has its own story and its own brightness, influencing our perception of the cosmos. The moon, in particular, has been a beacon of inspiration for poets and dreamers, acting as a mirror of our emotions and desires. What can we learn from its constant cycle of light and darkness? The Big Bang Theory reminds us that everything has a beginning, and that from nothing, a universe full of possibilities emerged. This monumental event not only marked the beginning of time and space, but also laid the foundations for the light and colour we perceive today. Reflecting on our cosmic origin invites us to consider our own existence and the impact we have on the world. Einstein's relativity offers us a new way of understanding light and time. It reminds us that our perception is not absolute and that, as we travel through the universe, our experiences can change. This concept can be extended to our daily lives, where perspective and time are flexible elements that shape our reality. Throughout history, scientists have conducted experiments that have unraveled the secrets of light and colour. These discoveries have not only expanded our knowledge, but have also inspired generations to look at the sky with curiosity and awe. Each discovery is a brick in the construction of our understanding of nature and the universe. The search for other worlds is a reflection of our innate desire to explore and discover. Understanding light and colour is crucial in this search, as it helps us identify exoplanets and look for signs of life in other corners of the universe. The idea that we may not be alone in this vast cosmos is both unsettling and exciting. The perception of the sky and space also has profound philosophical and cultural implications. From ancient civilizations that looked at the stars for answers, to philosophers who have reflected on existence and meaning, the sky has been an inexhaustible topic of inspiration and questioning. It leads us to consider our place in the universe and how our beliefs and values are interconnected with what we see in the sky. To close this journey of exploration and reflection, it is essential to remember that understanding the relationship between space and the atmosphere not only enriches our scientific knowledge, but also nourishes our spirit. It invites us to marvel at the beauty of the unknown and to find meaning in our connection with the cosmos. In the end, the darkness of space and the blue of the sky are constant reminders that, although small in the vastness of the universe, we are part of something much larger than ourselves.